Here is an interesting way of describing percentages. Let's say that we have two grades, 7th grade and 8th grade, and we have boys and girls in the two grades. In the 7th grade, there are 30 boys and 10 girls, and in the 8th grade, there's 25 boys and 35 girls. The total of all of the students is 100. If you add the boys and girls who are in the 7th grade, there's 40 of them. If you add the boys and girls in the 8th grade, there's 60. You'll notice that 40 plus 60 equals 100. Going down from this side, 55 and 45 equals 100. The list of here, 30 plus 10 makes 40. Right here, 25, 35, and 60. This makes it possible to say things like 45% of the students in the school are female. Why? Because we've got 100% as the total. And the girls, when you add up 10 and 35, you get 45. So that would be 45%. This is easy because we have everything adding up to 100. It becomes more interesting when we change it. So let's try right now. Notice what happens if we give you the total number and we tell you only a few of these numbers. We can usually find out all of the other ones. For example, if we know that all of the boys in the two grades are 110, and there's 60 in the 7th, then we must put 50 here. We know that all of the students are going to be 200, and the boys are 110, so how much are the girls? Exactly, they have to be 90. Now, we know that in the 8th grade, there's 120 students, and there's 50 boys. How many girls are there? Exactly. There must be 70, because the total is 120. So now we have 50 boys and 70 girls in the 8th grade. What else can we find out here? Precisely, because there's 90 girls total, and there are 70 in the 8th grade, we must have 20 in the 7th grade. And the final box gets filled in because we know that 60 and 20 makes 80. So this is a typical situation that happens in some of these questions. They give you only a few, and you have to fill in the other numbers.